And now we're going to do page 11 and 12 of the sequence and series bookwork. We're going to talk about the sum of series now. This is not going to be anything new to you. We've already talked about the equation for the sum of an arithmetic series. We derived it when we did our investigation. So basically, it is the average of the left and right side of the trapezoid times the width of the trapezoid, if you remember. And then you get this expression just by substituting, the term formula, which looks like this, okay? You put the term formula int for un, and then you get this expression here. So they're the same equation, it's just that sometimes you know the right side of the trapezoid, sometimes you know the nth term, and sometimes you don't. If you don't know the nth term, you can use this. But you could also use the term formula to figure out the value of the nth term and then put it in here. Okay, so really the only one you need to know is this and this, right? You don't have to use this one. Okay, for the series, 21 plus 23 plus 25, etc., all the way to 49, what is U1, D, and M? Well, U1 is obviously the first term, so that's 21. D is obviously the step, which is 2. N. Now, N is kind of hard, right? Because this is not a short sequence, so we need to figure out what number term that is. Now, 21 is 1, 22 is 2, 25 is 3, 27 is 4. Now, let's start counting on our fingers. Let's see. And we have 29 is 5, okay? 31, 33, 35, 37, 39. 39 is the 10th term. Okay. 41, 43, 45, 47, 49. So the 15th term is 49. Okay, so n equals 15. I just did that by counting on my fingers. Okay. Then what is un and sn for this case? Well, un is 49, right? It's the last term. What is sn? Well, we can use the formula above. So we could say sn is equal to n over 2 times u1 plus u2. And that n over n we know is 15, right? 15 divided by 2 over times 21 plus 49. Okay? So that's how you find the sum of that. Okay? And then now we're going to take a look at example 16 and 17, and then we'll do A and C. So find the sum of 3 plus 7 plus 11 plus 15, etc., to 20 terms. Okay? Now, since we do not know un, then if we want to do it all in one shot, we would use this equation here. So we would say, for A, we'd say S of n equals n over 2 times 2u1 plus n minus 1 times d. So we know n is 20, right? Because they said 20 terms. And we know u1 is 3, right? So we'll put those in. We'll say 2 times 3 plus, and n is 20, so it's going to be 19. And we know that d is, the difference between those is 4. So we're always jumping by 4, so d is 4. And n is 20, so 20 divided by 2 is 10. Okay, so it's 10 times 6 plus 19 times 4 is, I think, 76. Okay, so that would be 10 times 82, which is equal to 820. Okay, and then C, let's see, we would use a similar equation. We would use the same equation, except now, let's see, n is going to be 40, right? Divided by 2, and then inside we're going to put 2u1, and u1 is 100, so that 2u1 is 200, and then n minus 1 would be 39, and d would be, let's see, the step size here is negative 7, right? Okay, so we would do this with your calculator. 39 times negative 7 plus 200 times 20, okay? 2, let's see, find the sum of, and then they give us these two that we want to solve. So let's see, A, we're going to say u1 is 5. D is equal to, it's jumping by 3's, right? And we don't know n, we do know that un is equal to 101. Okay. Now we're going to use the term formula to find what n is, because we know everything is known except for n. So we're going to use un equals u1 plus n minus 1 times d. And I had made a mistake here earlier. un is equal to 101, right? So I'm going to put 101 here. And then now I'm going to use algebra to figure out what n is. So I subtract 5 from both sides, and I'll get 96 equals 3 times n minus 1. Divide both sides by 3, I get 32 equals n minus 1. So n is equal to 33, right? Once I know n is 33, then I may use the equation, either the sum equations, to figure out what the sum of the sequence is. So I have 33 divided by 2 times the first term, which is 5, plus the last term, which is 101. Okay? And then you can use the calculator to figure out what that value is. Okay, now C. Now in C, let's see, U1 is equal to 8. UN is equal to 83. D is equal to, let's see, 10.5 minus 8 is 2.5. Okay, and so we just don't know what n is. Again, you do the same thing. You use the term formula, and you are going to you're going to solve for n minus 1. So that would be 75 equals 2.5 times n minus 1. Divide both sides by 2.5. We get 30 equals n minus 1. N is equal to 31. Now that you know n, now you can go back and use this formula, the sum formula, to figure out what S sub n is, because you know D, you know U1, you know UN, and now you also know that n is 31. Okay? All right. Number 3, evaluate these arithmetic series, letter A and letter C. Now these, it says list the first 3 terms and the last term. Check your answer using technology. Let's list the 3 terms and the last term and see if it's worth doing with the calculator or if it's worth doing by hand. So the first term would be 1 times 2 plus 5, 1 times 2, which is 2, plus 5, which would be 7. And then the next term would be 2 times 2 plus 5 is 9. And the next one would be 11, of course. And what would be the last term? The last term would be 2 times 10, which is 20, plus 5, 25. Okay? And so you could use the sum formula, which remember looks like this, right? So you would have n would be 10, right? Because you know there's 10 terms. U1 is 7, right? And the last one is 25. Okay? So that's A. Now C, let's see, the first term would be, 1 plus 3, which would be 4, divided by 2, which is 2. The second term would be 5 divided by 2, which is 2.5. And then the last term would be, 20 plus 3 divided by 2. 23 divided by 2. Okay. And so now you could do this sum using the same formula, because we know there's 20 terms. And we take the first term plus the last term, and the last term, 23 divided by 2 is equal to 11.5, right? So you could solve it like that, and you could use your calculator also, okay, using the sequence and series button. Number 4. An arithmetic series has 7 terms. The first term is 5, the last term is 53. U1 equals 5, UN equals 53, n is equal to 7. Find the sum of the series. Okay, so we pretty much know everything we need, right? So the sum of the series would be n over 2 times u1 plus un, and we have all those. u1 is 5, un is 53, n is 7, so you can solve that with your calculator. Okay? Number 6. A bricklayer builds a triangular wall with layers of bricks as shown. If the bricklayer uses 171 bricks, how many layers did he build? Okay, so he has a sequence here, which is 1, 2, 3, 4, and it goes on until we don't know when, and that adds up to 171. So the series adds up to 171. We just don't know how long it goes. That's actually what they want to know. Okay, so like how many terms are there? How many layers are there? So let's see. Let's say that u1 is 1. un, we don't know. D is equal to 1, right? N is equal to we don't know. S sub n, we do know, it's 171, right? So now we can take that formula we have, S sub n equals, and remember the special case we have is n divided by 2, and then we have 2u1. This is the case where we don't know u of n. So since we don't know u of n, this one is useful. N minus 1 times d. Okay, so we do know u1 is 1. And we do know that d is 1. So let's simplify this. We have 171 equals n divided by 2 times 2 plus n minus 1. So that's equal n divided by 2. I'm sorry, 2 minus 1. So that would be equal to 1, n divided by 2 times 1 plus n. Okay? And so that's equal to, let's see, 1/2 n squared plus n equals 171. So now we can use algebra to make this into a quadratic. So we're going to multiply both sides by 2, and we'll have n squared plus n equals, and if we multiply this by 2, we'll get 342. Okay, and then that's equal to n squared plus n minus 342, and then that's equal to 0. And then we can use the quadratic equation to figure out what n is equal to. Okay, so n is equal to negative v plus or minus square root of b squared minus 4ac all over 2a. And what's that going to give us? And it turns out that n is 18. Okay. Let's see. 8. We're going to do A and C. Find the sum of the first 50 multiples of 11. And let's see, that would be, so u1 is equal to 11. And then let's see, so that would be u1 is equal to 11, n is equal to 50, right? D is equal to 11, because each step is 11, right? And then we use that to find the sum. So S sub n equals n divided by 2 times u1 plus n minus 1 times d. Oh, that's 2u1, sorry. So we just substitute those numbers in. 50 divided by 2. 2u1 is 22. N minus 1 is equal to 49. And d is 11. Okay, so you just use your calculator to figure out what S sub n would be there. Okay, that's A. Now here's C. For C, it says to find the sum of integers between 1 and 100 which are not divisible by 3. So that would be, let's see, 1, 2, you'd skip 3, and then 4, 5, skip 6, 7, 8, okay? They're being kind of tricky here. I think the easiest way to do this is, let's say, okay, find the sum of all the numbers from 1 through 100. Then subtract the sum of the numbers that are divisible by 3. For example, 3, 6, 9. So it's easier, I think, if we find the sum of 1 through 100, and then we subtract out the numbers that are divisible by 3. Okay, so for example, the numbers from 1 through 100, the sum would be, let's see, it would be 100 divided by 2 times U1 is 1, UN is 100. Okay, so that would be the sum of the numbers from 1 through 100. And then you would subtract the numbers that are divisible by 3. So that would be, let's see, U1 would be 3, D would be 3, UN is equal to, let's see, the last one would be like 99, right? Okay, and then N would be about 33, I think. Okay, so then we would have 33 divided by 2 times 3 plus 99. Okay, so that would be how you would find that. Okay, 9. Consider the series of odd numbers, 1 plus 3 plus 5 plus 7, etc. What is the nth odd number? UN. So then they just want a general term formula for this. So let's see. UN is equal to 1 plus n minus 1 times 2. Okay, that's the general term for this sequence. Prove that the sum of the first odd integers is n squared. Okay, so let's see. The sum would be equal to n over 2 times u1, which is 1, and un, which would be this expression that I just put here, u1 plus 1 n minus 1 times 2. So that's equal to n over 2, 2 plus 2n minus 2. So that's just equal to n divided by 2 times 2 times n, which is just n squared. So we just showed that, right? Check your answer to B by finding S1, S2, S3, and S4. Okay, so let's see. S1 is just equal to 1 plus itself, which is 1. S2 is equal to 1 plus 3, which is 4. S3 is equal to 1 plus 3 plus 5, which is 9. S4 is equal to 1 plus 3 plus 5 plus 7, which is 16. Oh, what do you know? Look at that. That's true, isn't it? So this is equal to 1 squared, this is equal to 2 squared, this is equal to 3 squared, and equal to 4 squared. Okay, cool. 11. 3 consecutive terms of an arithmetic sequence have a sum of 12 and a product of negative 80. Find the terms. Okay, so we have x minus d, we have x, and then we have x plus d. These are 3 consecutive terms of an arithmetic sequence. Now the sum of these is 12, and the product is negative 80. So the sum of x minus d plus x plus d is equal to 12. And the product of x minus d times x plus d is equal to negative 80. Okay, so we use these two equations and two unknowns to figure out what x and d are. Let's see, so if we look at this, negative d plus d, so they cancel out, right? So 3x is equal to 12. So x is equal to 4. So we've already found one of the variables. That was easy, wasn't it? And then we could substitute that in here. So that would be 4 minus d times 4 plus d is equal to negative 80. Okay, so 4 minus d times 4 plus d is equal to 4 squared minus d squared times 4 equals negative 80. So now we know this is 16 times. Now we'll divide both sides by 4, and then we'll have 4 squared minus d squared equals negative 20, right? And then let's rearrange this. 4 squared is 16, right? So we're going to write 16 instead of 4 squared. And then we'll put negative 16 on, subtract 16 from both sides. And that will give us negative 36 equals negative d squared. So that means that d is either going to be equal to plus or minus 6. And, basically it doesn't matter because sometimes we're subtracting 6, sometimes we're adding 6, so it doesn't matter if it's plus or minus 6. So the terms are going to be, the middle term is going to be 4. The previous term is going to be negative 4 minus 6, which is negative 2. And then the following term is going to be 10. Okay, so it's going to be negative 2, 4, and 10.